Often, you will want to concatenate data frames that share common row labels and common column names. Let's examine how concatenation works in that case. We begin by loading two small data frames from CSV files. The files contain monthly average rainfall for the first 3 months of 2013 and 2014 respectively. Examining the data frames Rain 2013 and Rain 2014, we see they have common row labels, the month abbreviations for January, February, and March. The column label Precipitation is also common to both data frames. We can concatenate the data frames Rain 2013 and Rain 2014 using concat with axis equals 0, the default. The resulting data frame has a single column with repeated index labels. This obscures the fact that the bottom 3 rows come from months of a different year than the top 3 rows. One fix is to use a multi-level index for the rows. Here, the argument keys equals 2013, 2014 assigns an outer index label associated with each of the original input data frames. Notice that the order of the list of keys must match the order of the list of input data frames. When printed, the data frame is displayed with distinct levels for the multi-index. This makes it clear which year is associated with each month for each row. As usual, the multi-index can be sliced on the outermost level with the .loc accessor. A different strategy is to concatenate the columns from the data frame Rain 2014 to the right of the columns of the data frame Rain 2013. We do this using the option axis equals 1 or axis equals columns in the call to concat. Unfortunately, since the column label Precipitation is common to both data frames, the result has 2 precipitation columns, again obscuring which column came from which year's data. Just as Pandas series can have repeated index labels, data frames can have repeated column labels. Slicing with a repeated column label yields all matching columns. To avoid repeated column indices, we use the options keys equals 2013, 2014 and axis equals columns with concat. The result has a multi-level column index showing precipitation by year. Again, we can slice the year 2013 in a dictionary type style. Finally, the function concat can also accept a dictionary rather than a list of data frames as input. In that case, the dictionary keys from raindict are automatically treated as values for the keys argument in building a multi-index on the columns. The result is the same data frame from before. Now it's your turn to work with multi-level indexes and concatenation in the exercises.